If you are visiting our channel for the first time, please subscribe first to get the latest updates. We have already found the domain and range of the ordered pairs in our previous lecture. But today we are going to learn how you can find the domain and range of the algebraic functions if you are not given with the ordered pairs but you are given with the function. This is a very important concept that you have to understand in order to find the domain and range of any function you are given with if it is in any form. So at the end of lecture you will be able to understand how you can find the domain and range of algebraic function, a simple algebraic function. Simple algebraic function, that is f of x is equals to x square. This is a simple algebraic function. Then we also discuss domain and range of functions with radical sign. In the numerator, example is f of x is equals to under root x square minus 9. This is an example that how you can find the domain and range of the functions like this. And you will also be able to learn how you can find the domain and range of functions with variables in denominator, like f of x is equals to x square minus 16 divided by x minus 4. How you can find the domain and range of the function like this. Then at the end, the domain and range of functions with radical sign in the denominator. So we can write as f of x is equals to 1 divided by under root x plus 2. So we have 4 cases. We have to check one by one how you can find the domain and range of all these 4 cases. So let's start with the case 1. If I'll say that these are the different cases, this is case 1, this is case 2, this is case 3, and this is case 4. So before understanding the concept of domain and range, we have seen in ordered pairs that domain is the first element of the ordered pair and range is the second element of the ordered pair. So let's see in terms of algebraic function how you can represent the domain and how you can find the domain and range of a function. Case number 1 is domain and range of simple algebraic function. So we'll start with the example. The example is f of x is equals to x square. This is the simplest example. Now how you can find its domain and range? Let's find it by considering like this. This is a function, that is f of x is equals to x square. Here will be the domain and here will be the range. This is just for the sake of simplicity. So this means domain is the input and range is the output. So the input and the output values are restricted to the function. That how the function is. If the function is the squaring of the given value. So let's find out some values of the y on some values of x so that we can understand its behavior. First of all, keep two things in your mind. That for finding the domain and range, you have to check the two things. One is, this is for the in the case of domain, you cannot divide the given function by 0. Okay, this is the restriction number 1. I'll say as restriction. This will be applicable in every case. Another is, you cannot take square root. You can't take square root of negative value as it will lead to imaginary number. And the domain and range should be real numbers, imaginary numbers. So these are the two conditions you have to check in every case. Even if the given function is f of x is equal to under root x, so you have to check both the values and both the conditions while finding the domain and range in case of algebraic functions. So let's find the domain and range of this given function by taking some random values of x and evaluating them on by evaluating the given function at different values of x. So we can evaluate as, if I put f of 1, it will give you with 1. If I'll put f of 2, it will give you with 4 because this is square. 2 square is 4. If I'll put f of 3, it will give you 9. But what if I put the negative values? If I put f of minus 1, what I will get? I'll get again 1. That is the same as f of 1. That is, it means that the given function is also inverting the negative values into positive values because of the square. Similarly, if I take f of minus 2, again I will get 4. If I take f of plus 2, f of minus 3, I will get 9. This means that for even the negative values of x, I will get the positive values of y. So let's write the domain and range as, let's write the domain and range here. The domain will be, now keeping this behavior in mind, what will be the domain? Keep in your mind that domain will be the set of real numbers. No imaginary number will be included. Now it means the given function we can take any value of x. It could be negative, it could be positive. Domain is the value of x. So here value of x is 1, 2, 3. Even I have taken minus values. So we are getting the real numbers in the output. It means you can get any value of x. So domain will be set of all real numbers. All real numbers. So whenever you can take any value of x, the domain will always be set of all real numbers. Now what will be the range? Range is basically the value of y or f of x that we will get after putting the value of x. That means the domain is this, range is this 1, 4, 9, 1, 4, 9. So it means when we put the value of x as negative, we get the positive values. It means range can never be negative. So we cannot say that range will be the set of all real numbers. We will say set of all non-negative real numbers because we have never got negative in the answer after evaluating the function. They as seen, even if at f of minus 1 we get 1, at f of minus 3 we get 9. So the range will be the set of non-negative real numbers, set of non-negative, or you can say positive real numbers. So this is how you can find the domain and range of the function, simple functions, by putting the values of x and phi and evaluating the behavior of the given function, that if we put what values of x, then what we get the value of y. So domain is the value of x and the and the range is the value of y. And you have to must check these two conditions. These are very important for finding the domain and range of the algebraic functions. Now we move towards the case 2. Case 2 is domain and range of radical functions, in which you have a radical sign. So we'll start with the example. F of x, the function is f of x is equals to under root x square minus 9. So this is the function. So we have to find its domain and range. First of all, we check the two conditions we have already seen in the case 1. Number 1, there is nothing in the division, so we cannot apply the condition 1, that is you cannot divide by 0. This condition will be applicable when there is something in the denominator. So we need not to check this condition, you cannot divide by 0. This condition is not required here. Second is, you cannot take square root of negative number. Take square root of, this is applicable here because we are having a square root in the function of negative number. So this means we have to find this condition in order to find the domain and range. So this is very important to check the condition number 2 for finding the domain. So let's first find the domain. What will be the domain? For finding the domain, we have to check what will be the value of x that should be included here to get a real number, because we have a under root. So in order to find that, we have a trick, that is the x square that the value in the under root should be greater than and equal to 0. If it is less than 0, we will get a negative value. So the condition is x square minus 9, that is the any expression in the under root should be greater than and equal to 0. You have to equate it like this, whatever the expression will be in the under root. So we have to evaluate it in order to find the value of x, and you have to always equate it with greater than and equal to 0, because if all the values that is less than 0 will be imaginary. So I will evaluate it further as x square, if we add 9 on both sides, will be greater than and equal to 9, or it can also be written as x is greater than and equal to plus minus 3, because we have a square. If we take the square root on both sides, we will get the two values of 3. It means this should be the value of x in order to find the domain. Now let's put this value of x in the given function to check we are getting the real numbers or not. Let's write it down as f of, as it is greater than and equal to plus 3 and minus 3, let's find on plus 3 as f of 3 is equals to under root 3 square is 9. 9 minus 9 is equal to 0. So we have not got any imaginary number. If we find it at f of minus 3, what will be? Minus 3 square is 9. Again 9 minus 9 equals to 0. Again we have not got any number that is imaginary. So if we found f of, they have said greater than 3 and minus 3. That is greater than, now x greater than equal to plus minus 3. What does it mean? It means that x should be less than and equal to minus 3 and greater than and equal to 3. That means that the value of x should be greater than 3, or the value of the value of x should be less than and equal to minus 3, because other than that, if we put the value will be, the f of x will give you with the imaginary number. So let's put any number that will give you the imaginary value. That is, they have said x should be, it means that the number between 3 and minus 3 should not be included. So if I put minus 2, what will we get? Minus 2 square is 4, minus 9, that is equals to under root minus 5. This is an imaginary number. Then f of minus 1 will be 1 minus 9, this is equal to minus 8. It means the value of x should be less than minus 3 and greater than 3. If we take any value between minus 3 and 3, it will give you with the imaginary number. So the domain will be, let's write it down, domain of f will be, you can write it as x belongs to R such that x is greater than and equal to 3. So we have written the absolute value, that is plus minus value will be included. It can also be written as minus infinity to minus 3, like this, union 3 to plus infinity. So this is the domain of the given function. Now how you can read it as? This is written in a way that minus infinity to minus 3, all the numbers from minus infinity to minus 3 will give the positive values of the given function, and all the numbers from 3 to plus infinity will give you with the positive value of the function, and any number between minus 3 and 3 will give you with the imaginary numbers. So this is another way of writing the domain, and you have in this, keep this in mind, these brackets. This parenthesis means that minus infinity will not be included, as minus infinity is a number that we cannot evaluate. This is just a representation. And minus 3, we have put the square bracket with minus 3. It means minus 3 will also be included because of this equality sign here. So minus 3 will also be included, and same is the case of 3 to plus infinity, that square bracket is with 3, that 3 will also be included. So keep these square brackets in your mind while writing the domain. Now we move towards the range. Range depends on domain. Keep this in mind. So for finding the domain, we have to check that what was the behavior of the range. But range, how, if we put the value of x, whatever the value of x we are putting, what we get. For example, if I say, if I put the value of range as f of, as the range is from minus infinity to minus 3, if I put minus 3, if I put minus 3, what we will get? We will get 0. If we put f of minus 10, what we will get? Minus 10 square is 100. 100 minus 9 is under root 91, and it will be a positive number. It means if we put any value of x in the given function, we will get a positive value of y. That means we will never get a negative value of y in this case. So what will be the range? Range will be equals to set of all positive real numbers. Or you can also say that the domain is from 0 to infinity. So range is from 0 to infinity. So this is how you can find the domain and range of the radical function. Now we move towards the case 3, where we have the fraction with the variable in the denominator. We have an example, that is, the function is g of x is equals to x square minus 16 divided by x minus 4. So let's find its domain first, and then the range. Again we have to use those two conditions that we have already seen. That is, the condition number 1 is you cannot divide by 0. So this will be applicable here. So we have to check that. So for that purpose, we will have to set the denominator equals to 0. So set the denominator. This is required in every function where we have a denominator while finding the domain. Set the denominator equal to 0. So what we will get? x minus 4 equals to 0, we will get x equals to 4. This means that we can never have the value of x equals to 4 because it will lead to the function to an undefined condition. So we can write as g of x is not defined at x is equals to 4 because it will lead to an undefined condition. 4 minus 4 is 0 and the denominator becomes equals to 0. So what will be the domain? Here we have to write the domain as domain of g will be equals to all real numbers except 4. That means we can put any value of x in the given function other than 4 because it will give you with an undefined function. Okay, now what is the range? As the second condition we have not checked, that is of that the square root of a negative number is not allowed because we don't have the square root here. So the range will be set of all real numbers because whatever the value we put here for x, we will get any value of pi. We can also check as, first I'll write set of all real numbers. How I came to know like that is, if I put the value, we can evaluate it at different values of x. That if I put g of 1, what we will get? 1 minus 16 divided by 1 minus 4, that is equals to minus 15 divided by minus 3, that is equals to 15 by 3. This is the positive value. If I put the value of g equals to minus 1, x equals to minus 1, I'll get the value of minus. We will also get the negative value. Why? Because we besides x square, we will also have the value of x, to which if we put minus value, we will also get the number the function at negative values as well. So we can say that the range of this function is the set of all real numbers, that we can also get the negative as well as the positive number. So we move towards the case number 4, that is the last case where we have radical expression in the denominator. So the example is y is equals to 1 divided by under root x plus 2. So let's find the domain first. As we have the under root here, so we have to check, as we have the under root as well as the denominator here, so we have to check both the conditions. So the condition number 1 is you can't divide by 0. For that we have to equate the expression in the denominator with the 0. So x plus 2 should not be equals to 0. So we can write as x should not be equal to minus 2. So the value of x that should not be taken is minus 2, because at minus 2 we will get 0 in the denominator. So other than minus 2, we can take any value of x that can be used to define the given function. So we have to check the second condition as well, that the under root the expression in the under root, you cannot take the square root of negative number. So we have to check that as well. So in under root x plus 2, if we write the values less than minus 2, we will get the number that will give you with the imaginary numbers. So first we have to equate the x plus 2 with greater than and equal to 0. So we can check what range should be included. So x plus 2 should be equal to greater than and equal to 0. And this means x should be greater than and equal to minus 2. This means that the value of x should be greater than and equal to minus 2 in order to avoid the imaginary values. So the domain that will be, we can write the domain is equals to, so the domain will be minus 2 to plus infinity. As I have written the parenthesis with minus 2 because minus 2 is not included. Minus 2 is not included here. But in this expression, we have found that x is greater than or equal to minus 2. But this condition is only in the case when the expression is in the numerator. So we have to take the first case as well with it by taking the condition of x is not equal to minus 2. So we have to write the domain from minus 2 to infinity. So then we have the range as range depends on the value of x. We can evaluate the range as one method is y is equals to 1 divided by under root x plus 2. If we solve this expression for expression as like by taking the square on both sides, we will get y square is equals to 1 divided by x plus 2, or we can further simplify it as x is equals to 1 divided by y square minus 2. Now from here we can find the range as the range will be the positive values of y because of the y square here. Okay, so the positive values we have to include, so the range will be 0 to plus infinity. So we can say that the range is, this is one other method of finding the range, that you can solve the given equation to find, here it is in the terms of y is equals to 1 over x plus 2. For finding the range you have to find the x, and from the given equation you can check that the value of y should be whatever the value of whatever the value of y we put, it will become positive. If we put minus, if we put minus 1, it will become plus 1. If we put minus 10, it will become plus 10. So the range will be 0 to infinity. So that's all from domain and range of algebraic functions, how you can find by in different cases. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.